Hello, hello. Most probably audio will be going. अब मैं मोबाइल नहीं उठाऊंगा, चेक करने दो. Let's go OBS. Okay. Um. Okay. What we are going to do actually? My main motive was to learn how we can implement OOPS in C. I want to re-implement the thing in re-implement the object-oriented programming concept in the C actually. Why this idea came in my mind? The very first question is, recently in my Google Summer of Code internship where I worked, I got to know about the GTK. GTK, the development GUI kit that all the Linux interfaces uses, and the amazing part was that they are using G-object. Yeah, they are using G-object. That's the very special thing. And what is G-object? This is basically a library that provides object-oriented OOPS concepts in the C language. So basically, they have created a custom library just to implement the OOP feature in the C, and that was very exciting for me. I got to know and learn about that, but throughout that time, I was curious that how I can implement that thing from scratch for myself, because I want to do it by myself. I want to see how we can implement it and learn it. So we are going to learn it, and we are going to do it in a structural way. I got a book which is object oriented programming in size C. Um, this is the book that we are going to work with. Well, let me show you. Oops, and size C. Uh, that's the book, I suppose. Yeah. Okay. Google.com, that's the best for. Oops, and size C. And that's the images. If you go, that's the book we are using. We are going to learn from this book actually, and that's the thing. So we will start by going through every single chapters. Like, as you can see, in first they talk about what is abstract data types, what are abstract data types, like information hiding. Then we got to know about dynamic linkage, the generic functions, how we can create a generic function, the programming side with the arithmetic expressions. Then we will go with inheritance in chapter 4, and the symbol table. I don't know what is basically the self thing, I suppose. Then a class hierarchy, OOC processor, preprocessor, something that we'll be learning, and defensive programming, dynamic checking. Yeah, there's too much to learn about, and this book covers every single thing like callback functions, pluggable memory leaks, also persistent object, exceptions, forwarding GUI, and actually I think we are creating and some GUI calculator also. So there's so many things to learn in this book, and I prefer that this book will be the best for us to learn the OOPS in C, and we can implement things from scratch without using any library or some library or any other thing. Let me again check if we are going live without any issue. This book, and I prefer that this book will be the best for us to learn the OOPS in C, and we can implement things from scratch without using any library or some library or any other thing. Okay. So let's read book and let's learn what actually is. So abstract data types and information hiding. So actually what we know about abstract data types, what it is means, basically what I know is that abstract data types are like your high the data type that means what is information hiding, kind of you are not exposed to the thing. It's just like a black box. Like if you're using a WhatsApp, you don't care what kind of encryption algorithm is used, you don't care what type of database model it is being used, you just only care about its functionality. Similarly, the person who is encrypting the things, the person who is on the encryption side, security side, he doesn't care how the data is stored, but he's more care about the encryption of it. And similarly, if we talk about the like the front end, like if we say escalator.com, okay, like if I say this is a backend engineer, okay, this is a backend one, and similarly, this is a front end one. Uh, yeah, I'm just making things very high level view. So while designing a software, front end engineer don't need to know what the backend exactly looks like, because backend provides you with the APIs. Yeah, they give you okay, sorry, they provide you APIs, uh, which you the front end person uses and implements it. He don't need to know what the encryption algorithm is, what are the things that the things are going on in a backend. So this is kind of information hiding. We are making things better, we are making things progress in a faster way. That's the thing, that's the kind of information hiding. We don't want to expose irregular. And if someone wants to work on a backend, he knows exactly what area of the things he's going to work on, and he knows exactly that particular thing. So kind of that's the front and back end I actually mean to say. What's information hiding actually is. So let's read data types. Data types are an integral part of every programming language. Okay, so yeah, as we can agree with this line that data types are an integral part, because any programming language you see, you start with the data type only. The int, float, char, all these are the starting point for us. So it's very important to have a data type in the programming language, like because without that, huh, in Python also we don't write data type, but yeah, actually internally they assign the data type to it. So data type is necessary actually. And size C has int, double, char, double and char, to name just a few. So they're just naming a few: int, double, char, float, and many more are there. Programmers are really programmers are really content with what's available, and a programming language normally provides facilities to build new data types from those that are predefined. So basically, we are not very concerned with what the language provides us, but we are more concerned regarding to build something new with that thing. Like we are not just limited to int, double, char, but we have gone so far that we have to create our own data type for that. So it's something unique actually. A simple approach is to form aggregates such as arrays, structure, and union. Like that's here the point he's saying. The very simple thing that we used to see in our day-to-day life, the arrays is just a group of integers or a group of characters. It can be anything. Structures, it can be the combination of int, double, char, any of the things. Unions, like that. So it doesn't matter. Means we, based on our need, we create many new things from the things that are already present. Okay. Pointers, according to CAR Hore, a step from which we may never recover, permit us to represent and manipulate data essentially unlimited complexity. Okay, that's the very great point that he is saying. Oh, so but first let us know who is CAR Hore. So he's the person who gave the idea of null pointer. So basically, the null terminology, the concept of null to be delivered in the programming language like C was given by C.A. Hoare. And according to him, pointers are very good, but it's a very dangerous thing also, because you know, because of the null pointer only we got the power to create a operating system and do many of the things, but it also created a problem, the never recoverable problem. It created the security issues. Now memory is not safe, you sometimes you can make it crash and many more things can happen. So according to CR Hoare, the pointers are very good. It's a very complicated thing, but it gives us a very good thing. But we may never recover because it will always give us some trouble during our production. So actually still the question is, what is exactly is a data type? What exactly is a data type? So we can take a several points of it. So a data type is a set of values. Char typically has 256 distinct values. So according to him, data type is a group of values, a set of values. Like char can store 256, int has many more, int can store 2 minus 1, 2 to power something, 2 to power something, 2. Both are evenly spaced and behave more or less like a natural numbers or integers of mathematics. Okay, so basically if you see the char or int, they behave mostly like integer natural numbers, and they follow the rules of mathematics. If you add, it will add that. If you subtract, it will subtract, and things go on. Double once again has many more values, and we know that int double have more values to store, but certainly do not behave like mathematics. Okay, so here's the line kind of thing. Double does not behave like mathematics real number. Why? Because he's saying, because if you see in after decimal like 0.3333, it can be never ending, but your compiler just end it on 0.333, or depending on the compiler 0.33. So it's not that same, because in mathematics 0.999 equal 1, it's equivalent to 1, but if you do in computer, it's not possible. Sorry. Okay, so it's kind of not possible in computer. Computer behaves more on the hardware, what the hardware provides, the features provided by the hardware. Where means restricted by the hardware actually. Alternatively, we can define a data type as a set of values plus operations to work with them. Okay, we can define a data type as a set of values plus operations to work on them. Typical, okay, so according to him, so data type is actually, if I say uh, data type is kind of why I'm just creating a boxes. Data type is equal to value set of values plus the types of operations we can perform. Like if I say integer values plus add, subtract, multiply, divide, all those we can do. So that's the data type actually. Typically the values are what a computer can represent, and the operations more or less reflect available hardware instructions. Int in inside C and it does not do too well in this respect. The set of values may vary between different machine, and operations like arithmetic right shift may behave differently. So as you see, not everything is working perfect in a computer. Like the right shift may not work that good. So because what the last bit is going to be, we don't know if that going to change or not. It's totally dependent on the compiler. More complicated example do not fare much better. Typically, we would define an element of a linear list like we created that, and for the operations we specify function header like node start that as. This approach, however, is quite sloppy. Good programming principles declare that we conceal the representation of data item and declare only the possible manipulation. That's the kind of information hiding. We hide the things. Simple. We call a data type abstract if we do not reveal its representation to the user. Okay, we call things abstract if it's not available to user. not visible to. At a theoretical level, this requires us to specify the properties of the data type by mathematical exams involving the possible operation. Okay, so like these books are just add so many information in the one line only. Was the mathematical exams mean, like, in mathematics you don't have the proof of the basic things, but based on the exams they guarantee us that you go on, these things are possible. You just believe me, what I'm saying is this is exist, you can work on this, you can take this and work on it. So it's just like the data type. Your your backend gives the APIs. The front-end engineer just has to believe the backend developer, the APIs that he's giving. He just believes that blindly. He don't need to see the code and all. He just believes blindly on the APIs and create the thing. For example, we can remove an element from a queue only as often as we had added one previously, and we retrieve the elements in the same order in which they were added. So in queue, we know that we can only remove element until and unless we have added one, and we can retrieve the same elements in the same order, first in, first out. Abstract data types offer great flexibility to the programmer. Of course, that's the basic thing. This starts to give a great programming experience. Since the representation is not a part of the definition, we are free to choose whatever is easiest or most efficient to implement. If we manage to distribute the necessary information correctly, use of the data type and our choice of implementation are totally independent. Abstract data types satisfy the good programming principles of information hiding and divide and conquer. Information such as the representation of data item is given only to the one with a need to know. To the implementer and not to the user. With an abstract data type, we cleanly separate the programming task of implementation and usage. We are well on our way to decompose a large system into smaller module. So basically what happens when you try to hide the things, you came up to a point that you divide the things, and when you start breaking things, things become very uh, decomposable, like smaller modules are there. Now you don't have to look at the whole thing, but there are very small things that you have to work on. Like, I can give you the better example, like the kernel. There's a kernel. This is a whole kernel, um, and it have Wi-Fi driver, like when you're working with network. Okay, like you're working with a, what we can say, sound, when you're working with a memory, like that. So in kernel things are divided, you don't, and that's the core, the processor. No, processor. So when a kernel developer comes to work in, he don't need to know the processor things, he just can work independently on a network. He doesn't care what the processor data type is doing or not. Processor provides some APIs, it provides some APIs, it provide it provide the it provides the APIs, to all, and they just know that I have to use these APIs and create the network thing. I just use this API and create the sound thing. I just use this API and create the memory part. So it's just like this. We broke the complete thing into the smaller parts. Okay. So it's just like this. We broke the complete thing into the smaller parts. Wait. An example. So how do we implement an abstract data type? Okay. Now here comes the part, like the example thing, that's the very interesting thing. We are going to be very practical in this book, I suppose. So we are going to create a set, an example. So how do we implement an abstract data type? How do we going to implement that particular thing? As an example, we consider a set of elements with the operations add, find, and drop. Okay, so kind of what he's going to do, he's going to implement the abstract data type, and that set basically have add, find, and a drop thing. You can add things, you can find things, or you can delete the things. Basically, why not drop asterisk? Okay, unfortunately remove is an SI. Okay, got it. There is a remove thing already present in a NSI, so we cannot use the remove, so he's taking the word drop. They all apply to a set, and an element and return the element added to, found in, or removed to the set. As I said, find can be used to implement a condition contains, which tell us whether an element is already okay. We can use the find to find if it contains or not. So we have basically the four things that the set is going to do. We have four things, like the set is going to have four things. What is first? You can add, you can find, you can drop, and you can check contains. Okay, this contain is came from that particular thing only. That is the thing that make this possible. So this is the set that we are going to make. Okay, viewed this way, set is an abstract data type. We are going to create something like abstract. To declare what we can do is with the set, we start with a header file set.h. Okay, we are going to create a file set.h, and in that we're going to write these things. This is the basically, I think so, what it is. This is the blueprint. This is the blueprint, or we can say this is the APIs from which a developer can see and learn that these are the things that are provided by the set currently, and you can see and do that. Yes. Okay, so if I just open the PowerShell, um I don't know how to. I think that's, well, I don't think that I feel well, so we will start this stream after some time actually. It's, and also I do need to fix the OBS because the terminal is not getting visible. I have to just again move things up and down to make things visible. Like now you see the terminal, but the this window starts to display, so actually I have to need to set all it also. Well, okay, see you after some time.